This lesson will talk about the calculation of the structural elements of a building. So I'm drawing a building here, its structural elements, which are this one is the slab. This carry the load when we are standing at one building. These are the columns. And this is a beam. So if we cut the building in here and we take a loop, we'll have the slab layers which are the first are the tiles, the second is the mortar, the third one is the sand, and another element is the slab, the concrete slab. A concrete slab is a mixture between concrete and bricks or or polyester. The bricks and the polyester is used to to have a lighter weight and the same carrying capacity of the slab here. To calculate the load of the slab, we have to calculate two loads, the dead load and the light load. The dead load is a permanent load, and are these the tile, the mortar, the sand, and the bricks and the concrete. To calculate these, we have to calculate all the thicknesses of these elements, and then we multiply these. If I can make some examples. These are all in meters. To calculate the weight of the tiles, we multiply the thickness of the tile with the weight of the tile per unit. It's data Newton per square meter. And we multiply it with a coefficient, which is a safety coefficient. Then we calculate the load of the mortar, the sand, and the slab. To calculate the slab, we have T sections. All this is concrete. These two sections in here are bricks or polyester. So to calculate the load of the slab, we calculate the concrete with the T section, we divide it in square areas, and then we calculate the load of the bricks, and we sum that, both these loads, and we take the sum and the load of all the slab. After having all the loads here, we take a sum, and this will be the dead load of our slab. We calculate the live load. We have a given live load, for example, 200 live load, P. This is marked with G. P is 200 decanewton per square meter. We have the sum of these two loads, the dead load and the live load, and we have Q equal to P plus G. After having calculated the load of the slab, we take a calculation scheme for the slab, because this is a T section. The scheme is this. This represents the load, the Q load, and this represents the slab. So if we draw the diagram of the moment, we'll have this is the diagram of the moment, and we know that the moment, the maximum moment, is in half space because the moment is a product of the force with the distance, and the maximum distance is in middle space here. The diagram of the force is this. The maximum force is the two supporting points in here and in here. We have maximum force, which is marked by BQ. Then we can calculate the moments. The formula for calculating the moment is the product of Q and L square divided by 8, and Q itself is the product of little q with L divided by 2. To calculate the reinforcement of the slab, we have these formulas. A0 is equal to M divided by BF multiplied by H0 square and RB. So BF and H0 square is the dimensions of the slab, but in this moment we take it as it was a square section. So this is BF and this is H0 and this is BF. After calculating A0, we calculate C, which is 1 minus the root of 1 minus 2 A0. And finally, we calculate the reinforcement, which is C, the product of C, B, HF, RB divided by RC. RB is the concrete resistance, and RC is steel resistance. So the reinforcement is the steel that carry the load in the down part of the slab in here. We put the rebars in here. After calculating this, we pass to the okay. Next lesson we will calculate the beams, columns, and foundations. Thank you.